Hello everyone, we are Group 16 from Industrial Engineering Ubaya, and we will present about our facility layout project. So this is my team. I'm Elsa, and this is Shiddiq, this is Bryan, this is Nabilah, and this is Gusti. The first project, Operational Process Chart. PT Dipal Medicare produce toys children with a special need, namely autism. Currently, the product that PT Dipal Medicare will design is a 3-in-1 playbook, which has 3 functions in the one package to answer the needs of the 3 levels of children with autism. So, you can see the operational process chart, the function of the OPC, to describe the step of the material processing process, starting from raw material to the component or finished product. There are OPC of playbook 3-in-1. There have a 6 component that must be made. The first component is a rectangle with MDF raw material. The second is a pound with MDF raw material. The third is left and right cover with MDF raw material. The fourth is the top and the bottom cover with MDF raw material. The fifth is a cube with multi-packs material, and the last card made of polywood. After each component have been made, all components will be combined and will be wrapped and inspected. The second project is the routing sheet. The routing sheet is a function to calculate the number of machine needs and to calculate the number of the part that must be prepared is an effort of obtain the desired number of the product. Before we do routing sheet, PT Dipal Medicare needs to take into account the amount of market demand for the product it makes. This is done by forecasting to determine the amount of expenditure allocated for product development and marketing for the next 5 years. So, you will get the optimum number of the machine and operator. In this project, we need 68 operator and we need 32 machine. With a details, 6 circle machine with 12 operator, 5 thrust machine with 5 operator, 5 jigsaw machine with 5 operator, 5 WSB machine with 5 operator, 7 assembly table with 37 operator, 2 jointer machine with 2 operator, 2 planer machine and with 2 operator.
Okay, next, project 3, space requirement. Using space requirement calculation, space requirements aims to find out the slot area and floor area required for each product to be stored in the production room and warehouse so that the room is not too narrow or too wide. After calculation of machine dimension table, component dimension table, raw material dimension table, large component dimension table against machine, and large raw material dimension table against machine. In the table need space will be obtained total space from each type of machine. The total space that requires the most area of assembly machinery is 296.9475 square meters and everything total, so that the total required for production, floors, and warehouses is 643.762.815 square meters. Okay, next, project 4, from to chart and iteration. Basic layout. The purpose of from to chart is to plan the layout of a factory and transfer in production process so as to show the total load quick so from the transfer of bearing from one machine to another and consider the location of the machine in the production room. Can be seen in the table. The total weight at each recapitulation state is to sum the weight of each related operation. In doing the transfer of semi-finished product, need to know the weight so that the production process can run smoothly. The greater the weight, the greater the production space needed, or vice versa, and can know the need for a large production space in order to be better and efficient. Next iteration. Of the 4 iterations that have been done with different machine sequences in each iteration, the selected iteration is iteration 4 because the total result is the least is 2632009.3187 kilogram per seed. With our storage, to circle machine, to RAS machine, to jigsaw machine, to WSB machine, to assembly table, to jointer machine, and to planar machine displacement of each machine the best.
In the fifth project, the goal to be achieved is to determine the optimal layout of the machine by minimizing the cost of moving items. Basically, every movement of goods is considered as a cost. So, we need to simplify process by combining, shortening, or eliminating unnecessary moves to reduce work. On the screen, we can see the optimal layout based on the output of the Lingo software. The layout is also made from the floating result. The order of the machine used is based on the smallest to largest number. A first machine is a shuffle machine. Second is RAS machine. The third is jigsaw machine. And the fourth is WSB machine. And the fifth is an assembly machine. Sixth is a jointer machine. And the last is a planar machine. Sundares in his book Fasilitas Design states that the layout must have the following objectives. The objective number 1 is minimize unnecessary personal movement within the building or floor. Objective number 2 is facilitate communication and provide privacy where necessary. Number 3, conform to building codes. And number 4, provides the safety and security for people in the building.
Determining the proximity of the machine beforehand, we arrange the closest room according to the function and the needs the employees. To determine the proximity between one room to another, we use RRC. Example, the proximity of the production floor and raw material warehouse. In our opinion, the two rooms should be close together because the comparison of raw material and the production floor does not take long and reduces the cost of moving raw materials. Then there are lockers and toilet. In our opinion, there are as needed for locker and toilet, so these two rooms are not close. Then we come back to dimension to view and adjust the proximity based on the most important. After that, we look the number of legs then needed. In determining the number of legs, we use the illumination level based on the needs in each room. The example of our production floor, we use 500 looks due to assembly for fence category, CU 0.8 and LLF 0.85. We determine the sprinkler according to the need in each room that has a different area. For a protection of 70 or 78.5, we get 32 sprinkle points. We specify a cyclone, but not all rooms use it. Only on the production floor room, material warehouse, finished product warehouse, and the toilet. The total results 26 sprinklers. 26 cyclone. For the personal requirements are considered according to the number of employees is 100 employees. There are 2 toilets consisting of 2 rooms, male and female. The whole room has one consisting of 1 bed, 1 nurse, and 2 chairs. We also adjust the canteen to needs of employees for 505. The parking always consists of 3 standard car, large car, and motorbike. And consisting 10 standard car, 3 large car, and 22 motorbike. Each type has different size for standard cars is 50.65 car and 70.65 for large car. Then we make locker according to this production floor. We match the size of the must security post and the office. With this, the size equation is made for custom and the custom cost. For the ranges, a custom cost. We provide an allowance for each room in order to facilitate user facility system. Okay, this for the dimension, and for the example is for production floor must close with material warehouse. Okay, next. Okay, for location, we determine we use CVM based on the character determined by its location. In the SFM table is determined by the weight that has determined based on existing interest. Meanwhile, its OFM is meant based on the raw material transportation cost, transportation of finished product cost, land prices, and PV and taxes. Then after calculating each location, the base obtained is base LM 0.9275. And this is the most optimal is location the Banjarnegara, because the Banjarnegara is minimizing cost and the best character. Okay.
And now for the cost part. In determining the cost of goods sold, there is a prior calculation of the price to be sold for profit by calculating raw materials, labor, additional costs, and others. The cost of goods sold main purpose is to determine the cost incurred in producing products, and for the cost itself divided by two parts, which is manufacturing cost and the non-manufacturing cost. In the manufacturing cost, the first one is the direct raw material cost, which consists of all the raw materials used in the production process. Second, additional material cost consists of all the additional material used in the production process. Third is the direct labor cost, consists of the cost of the people that works directly with the production process, such as operators. Fourth, the overhead cost is the costs that are not directly related to the production process. And then, lastly, the material handling cost is the cost that incurred in the materials activity that move from one machine to another machine. We move on to the non-manufacturing cost, consists of the indirect labor cost, which is the cost of the people that doesn't work directly with the production process, such as managers or directors and others. And then lastly, the depreciation expense consists of the production cost from the depreciation of our assets. Therefore, the total cost of goods sold per unit of our company is 303,624 rupees. Now we move on to our 3D layout view. From the first row, from the left to right, the first one is the main office, the second one is the parking area. In the second row, from the left to right, the first one is canteen, the second one is raw material warehouse, the third one is the finished product warehouse. And the last row, the first one from the left is the player room, next to it is the production floor, and the last one is the waste disposal. Okay everyone, we hope we give you all a nice presentation. Thank you for all your attention.